How do bubbles create perfect hexagonal shapes? Imagine a tiny soap bubble floating in the air. When many bubbles come together, they often form a stunning honeycomb of shapes. Have you ever wondered why these shapes are usually hexagons? It all comes down to how bubbles behave when they pack together. Bubbles naturally try to minimize their surface energy, which is the energy needed to keep their surface intact. A single bubble is spherical because a sphere has the smallest possible surface area for its volume. But when bubbles touch, their surfaces flatten where they meet to reduce the total surface area and energy. This flattening creates flat faces between bubbles. As more bubbles cluster, these flat faces tend to form a pattern that repeats over and over. Hexagons are the shape that fits together perfectly without gaps, sharing walls equally among neighboring bubbles. This pattern is called a tessellation, and it is the most efficient way to cover a surface with shapes of the same size and shape. The reason hexagons are so common in natural patterns is because they use the least amount of material to fill space while maintaining stability. This idea is similar to the honeycomb structure made by bees, which is also made of hexagons. The hexagonal pattern emerges naturally because it balances the forces acting on the bubbles, like pressure differences inside and outside each bubble, and the surface tension pulling on the walls. These forces push the bubbles into a shape that is both stable and efficient. From a numbers perspective, hexagons have 6 equal sides and angles, making them symmetrical and easy to analyze mathematically. This shape appears often in nature because it is so effective at filling space with minimal energy. Understanding this pattern helps scientists design better materials, like foams and porous substances, and even improve technologies that involve bubbles or foam-like structures. So, the next time you see a cluster of bubbles, remember that their perfect hexagonal shapes are a beautiful example of how nature uses simple mathematical principles to create efficient and eye-catching patterns.